Hi everyone, it's Coach Fred here, and I'm going to go back to writing inequalities with word problems and look at another example. This time we're going to look at an example that involves a shape, okay? So maybe those involving something that includes length and width of shapes. So the first thing I want to do is I want to look at recalling the perimeter of a rectangle. If I give you a rectangle that has length L and width W, if I want to find the perimeter, I'm pretty sure that most of you would say the perimeter is all the way around it, okay, it goes all the way around the sides. But if I wanted to turn that into, say, a formula, then that formula that we came up with last year was that perimeter was equal to 2 lengths plus 2 W's. It was just a simple way to find the perimeter. All right, so we're going to use that and try and write an inequality. So let's look at what we got. The length of a rectangle is 4 centimeters longer than the width. The perimeter is no more than 28 centimeters. All right, well, first of all, when we're writing these inequalities, we're looking for one variable. And I always tend to, when I make my let statements and use rectangles, I like to go with the smaller value for my variable. And the width is always smaller, so I'm going to let W equal the width. Okay, now remember, we're writing an equation or an inequality in one variable. So when we write the length, we have to do it in terms of the width. That means with W in my expression. So for the length, we know it's 4 centimeters longer, so W plus 4 would be my length. Okay, so now we want the perimeter of this. I'm going to draw a picture of it because every time I have a rectangle, it just makes it a little bit easier for me if I can see a picture of it. All right. So we want the perimeter, we want P to be no more than 28 centimeters. So we need the perimeter to be less than or equal to 28. All right, so we can either plug right into the formula or we can add up all the sides. So we can say that 2 times W plus 4 plus 2 times W has to be less than or equal to 28. All right, so that's an example involving a shape using perimeter, or this could also be area. We're not going to solve it. I just wanted you to get to write the inequality. All right, let's look at another example. This example involves either integers, consecutive integers, or consecutive odd and even integers. So in our previous video on inequalities and in class, we talked about integers. Integers are positive and negative whole numbers. And I tend to use the variable n for an integer. But you can really use any variable you want. Remember, a variable is just a way to write something that's unknown to us. All right, but when we're talking about consecutive integers, we said that the first integer was n, the second one would be n plus 1. But that's not the case with consecutive odd and even integers. Let's look at some consecutive odd and even integers for a second. 3 and 5 are consecutive odd integers, so they're every other odd number, or every next odd number. And even would be like 2 and 4. Notice these are both, in both cases, 2 away from each other. So if we let n be the integer, then a consecutive odd or even integer is going to be n plus 2. All right, so let's look at an example of how we'd write an inequality using integers. This question says the sum of 3 consecutive odd integers is no less than 51. Okay, so I'm going to first let n equal the first integer. All right, so because I'm talking about odd integers, the next one would be n plus 2. The question says the sum, so sum means add, so n plus 2, is no less than 51. So no less than means greater than or equal to 51. So that would be the inequality to solve for odd integers. All right, guys, so I don't want you to solve. Again, we were just practicing the concept of writing the inequalities. We'll be solving these tomorrow in class as well as writing them. I hope this was helpful. Have a great day.